Okay, so in this one, we're going to miscolor this. We're looking for k and for f in this equation, right? So what we're going to do is set up synthetic division. We have our lines here. We bring down the coefficients of all the numbers. So we start with cubes. So we have 2, 1, now -2, and then technically k, and f. Okay. In our first example, and we're going to have to actually do 2 examples of this because they've given us 2, right? So we have one set up, and then we're just going to copy and paste this for the second one. Perfect. Okay. In the first example, we're going to divide by the factor of +1. A little room here. And the second example by -2. So we have +1 going into this one, and then we have -2 in this one. What's important here are our remainders. We already know what the end answer is going to be. The end answer here for a remainder is going to be -4, and the remainder over here is going to be 11. Does that idea make sense? Mm-hmm. Okay. So what we're going to try to do is we're going to try to go through this and see if we can't make an equation from what our variables are. So when we divide the first one, we bring down the 2. 2 by 1 is 2. We add them, we get 3. 3. Okay. So then what's happening here is we're going to get some value, and when we multiply it by 1, which is really nice because 1 makes it really simple to multiply by, we're going to bring this number up here, and our remainder is going to be 4. Okay? So essentially, we have to find a number that when we're going to make an equation out of this. When we add -2 times k plus 3, it's going to be equal to f plus whatever this number is to equal 4. So we're going to try to make 2 little equations out of this. Okay? So like we said before, we know we're going to make one equation that says 2k. What did we say it was plus? Plus 3, right? Yeah. Plus 3 is going to be equal to some number, so we'll call that number x in this one, right? And x is also going to be f subtract, so we're going to call this number our x. It just so happens that this would technically be x times 1, because we'd have to multiply it by 1, but because 1 doesn't change anything, this number here is also going to be x. Okay. Is that idea? Okay. So we get f plus x is going to equal -4. So we've essentially made 2 equations out of this. Our f plus x is going to be -4. Okay, so those are our first set of equations from our first one. Let's do the same stuff with the other one and see if we can start putting equations together. So same idea, we bring down the 2. -2 times 2 is -4. When we add that together, we get -3. -3 times 2 gives us +6. Okay, now, this is where it's a little different. We know we're going to have to multiply this value here by our -2. So this value is going to be -2 times, and we'll call this variable, let's say our, we'll call this y. Okay, so whatever this is, this y, we have to multiply it by -2. So again, we can make another set of equations out of this. -2 times k plus 6 is equal to our y. And we also have f plus -2 times y. We've got 3 variables here. That's good because we have 4 equations. Equals 11. Okay. So with our variables, I'm going to highlight our x so we can kind of make sense of this. We need to start solving for variables here. Okay. One of the things we can do is a substitution method, right? We have an x. I can plug this value into here. So then I'll be dealing with an f and a k in here in one equation. What we're trying to do is get all the variables the same in one equation. So we're going to have to go through several steps of substitution in this. Quickly looking off the top of my head, there's probably a very quick way to do this, but let's say we're a little unsure how to go about it. We're going to just start substituting until we end up with an equation that has only one variable in it and just numbers. Once we have that, we can start solving for one of the variables, depending on what the equation is going to include. Okay. So right off the bat, actually, this is exactly how we're going to do this now that I look at it. What we're going to do is we're going to take this x value, and we're going to plug that amount in for the x in this equation. Okay, so we're going to plug that in for the x. And same idea on our set on the left. We have our y value. We're going to replace the y with exactly what it is equal to. Okay, so we're going to multiply 2 by those two numbers. I'm going to tell you what's going to happen. In the end, we're going to have two equations then. This one here is just going to deal with f and obviously k. And this one here is going to have f and k. And then we can start doing substitution again to solve for specifically f and k. But we actually got to find values of x and y first. So our first set, and I'll call this our second set of equations. In our first set of equations, we're going to end up, and I'll write the rest in black from here on, f plus, we replace x with, I'll write that in red so you just realize it, 2k plus 3 is equal to negative 4. Okay, so pretty much what we're going to do here is we're just going to try to simplify. We have f plus 2k plus 3 equals negative 4. When I bring the 3 over, I have f plus 2k is equal to negative 7. Does that make sense?
Yeah.
Okay. And in our second set of equations, same idea, f plus, in this one we have negative 2 multiplied by our y in this one is negative 2k plus 6.
Do you expand that first?
Yeah, well, we're going to use distributive properties. So we got to multiply that negative 2 by both terms. So we have f plus 4k.
Minus 12.
Yeah, minus 12 equals 11. When we bring that over, we have f plus 4k is equal to 23. When we bring 12 over, it becomes positive, right? Okay. So now we're stuck with, not stuck, sorry. We have another set of equations. We're going to rename them again. I'm going to call this equation 1 and equation 2. This will be equation 1, where we have f, and we're going to try to put the colors back together again. F plus 2k is equal to negative 7. And this one we're equal to 23. That's plus 4. Okay. Plus 4, we have our k. So now we have our two equations, and it's the same idea as before. We're going to do substitution. Now, in order to do substitution, we need to set one of these equations equal to a variable, right? Looking at it, either 1 or 2 will be easiest to set equal to f, because all we'll have to do is move the other k variable with the coefficient to the other side. So say we work with equation 1. So in equation 1, I'll write it in black now, we're going to have f is equal to negative 7, and when I bring 2k to the other side, we get negative 2k. Okay. Now what I have is a value for just f, and I can plug that into the other equation. So we're going to plug this value in for the equation into our second set. So what we'll have is negative 7 minus 2k plus 4k equals 23. Is this making sense?
Yeah.
A lot of substitution in this question because there's so much they've asked. Now we start to simplify. Negative 7 minus 2k plus 4k equals 23. Okay.
Yeah.
Combine like terms, we get 2k, and when I bring the 7 over, it becomes 30. K will be 15. So now that we have a k value, we can plug this amount into either equation 1 or 2 to find out for the f value. So say we do equation 1 again. 1 f plus 2 times k, and this one is 15, equals negative 7. That becomes f plus 30 is equal to negative 7. Our f value ends up being negative 37, right? So let's go try to make sense of this on the next page. So f is negative 37, k is 15. So okay, so here's a polynomial again, and we discovered that f was negative 37 and our k factor was 15.
Yeah, so we can sub that in.
Yeah, so we'd sub those in. Really quickly, we'd end up with a polynomial that reads 2x cubed plus x squared. Then you have negative 2 times 15, so that's going to give us negative 30x and minus 37. Now, we can synthetic factor to check if we like. Let's see if we get negative 4, and if we synthetic factor by negative 2, see if we get 11 as remainders. They might actually want you to, by the looks of their answer, they might actually want you to find a real factor now and factor this equation. Okay, which is probably what they're going for. So let's trial and error find out what is a factor of this. All right, so we finally realized we made a small error where we should have put negative 2k in. I'm going to go through this quickly. Okay, so negative 2k gives us this. This would be negative. This becomes f minus 2k. Okay. Did I use it in any other ones? No, I think everything else is okay from there. F plus x equals negative 4. That's right. Right. And we used positive 1 just to double check. Yeah, we did use positive 1. Okay, good. So this becomes f minus 2k. So this becomes f minus 2k. Let's see how this changes things for us. When we move it over, this becomes plus 2k. Are you following?
Yeah.
Okay. Plus 2k. We took this value, should be plus 2k, which would make this 6.
Why isn't that one minus 2k?
Here?
Yeah.
Because what I had done here is I isolated for f, the first equation, and I
Oh, they
moved
got it
it
away.
over, so it became positive. Okay? I know I'm going very quickly here. Just want to correct that mistake. So this becomes negative 7 plus 2k. So what ends up happening here is you get negative 7 plus 2k plus 4k.
So 6k.
6 divide 30 gives us our 5. We plug 5 in very quickly. 5 gives us 10. Again, sorry, we plug this in. This equation should read negative. So we have negative 10. When it comes over, is the answer 3?
Yeah.
Answer should be 3.
Okay.
Okay. So sorry about that. Okay. It says Chris makes an open top box, right? From cutting out from a piece of cardboard. Oh, I should have made it since it's 30 by 30. I'll make these 3 by 3. Here we go. It said it was 30 centimeters by 30 centimeters, this cardboard? Okay, so 30 centimeters by 30 centimeters. That'll be a 0. There we go. Worked out nice. He makes an open top box. So essentially what they're saying here is it's going to look something like this. The box. Okay. But imagine that there is kind of like a hole here. So it's wholly in there. I guess I can do this. Close enough. Okay, so there's our open top box. It says that he does this by cutting out equal squares from the corners and folding the flaps up. So in other words, what he needs to do is he needs to slice this and this. Let's do this with lines. He cuts a corner here out, cuts a corner here out, cuts a corner here out, and cuts a corner here out. And then what he's going to do is he's going to flip this up, flip this up, flip this up, and flip this up to make a box with a hole in the top.
Okay.
Does that idea make sense? So these are gone. They've been cut out of the cardboard, these things. It says when he makes these cuts, equal squares, by cutting out equal squares. So these are equal squares. Essentially, we don't know how large they are, so we're going to call them x. The length and the width of each of these, because they're squares, are x. Okay? So that's what we know from here. And we know that what are the dimensions of each square to the nearest hundredth of a centimeter, so that the volume of the box is 1,000 centimeters cubed. So our volume is 1,000 centimeters cubed. Okay? So they're referring to this box here having a specific volume. We need to figure out what the length, the width, and the height of this box are. Now I know I've drawn a rectangular box, but because these are all even and we started with an even lengths and widths, we're essentially dealing with a cube. We're going to have some type of cube here. We also know that technically the length of the box is actually just that far. Does that make sense? The width of the box is technically this length, so this will be the width. This is the width of our box. And finally, No, actually, this is the width of our box. So I'll do that. This is the width of our box, which is the exact same as what I've done before. And the height of our box is essentially one of those. Okay? So really, they're all the exact same. Like we said, there is a cube. So we do know these distances. I know that the total distance here of, let's say, we'll call this, what did we say that was going to be? The length. We know that the length is going to be equal to the number 30. Subtract what? Subtract this measurement, which is 1x. This measurement, which is 1x.
Okay.
So together it would be subtracting 2x. Does that idea make sense? All right. Since this is the same length here, same idea. We're going to have 30 for our width. Our width is going to be the exact same measurement. Remember we said it was a cube, right?
Yeah.
So then we can assume what's the height?
The same thing.
Exact same thing. We discussed how it was going to be a cube. So those are our measurements. Our height is also going to be, because this is technically, oh sorry, let me just double check.
Yep.
Height. Sorry, made a mistake. The height is just x, because remember, we're talking about only this. When these get folded up, that's the height, and the only measurement we have for those are x. So the height is actually just the number x. So we have these together. There we go. What we're going to have to do is, in order to find volume, we multiply our length times our width times our height, correct?
Mm-hmm.
So we have our length, our width, and our height. We're going to plug these values in for length, width, and height. So the volume, which is the number 1, that's not 1,000, it's the number 1,000 centimeters cubed. Our length is 30 minus 2x.
Do you not solve that?
Yeah, we're going to solve this.
Oh, okay.
Yeah. Times 30 minus 2x times x. Okay. Now, what we're trying to find is the actual amounts, right? In order to do this, we actually have to set this equal to 0. So I would, first of all, I can expand all of this, but in order to set this equal to 0, this 1,000 has to come to the other side of the equation. Okay? So we get 0 is equal to 30 minus 2x times 30 minus 2x times x minus 1,000. Is this making sense? Obviously, we're going to have to FOIL, so I'll quickly go through this. This is going to give us 900, 30 times 30. 30 times negative 2 is negative 60. I'll go one step at a time for you. Minus 60 again, which is negative 2x times 30. Negative 2x times negative 2x is positive 4x squared. Still needs to be multiplied by x minus 1,000. Okay. These are going to be a negative 120x, but when we distribute the x, we're going to have.
Why do you have to multiply by x though?
Because I never actually multiplied the height. I FOILed, so I did 30 by 30. I did 30 by negative 2x. I did negative 2x by 30.
Right.
Yeah, does that make sense?
Yeah.
And here, but I never multiplied by my height still. I only did one step at a time. So I still have to distribute my x value onto all of these. Now we know that this one's just going to be negative 120x and times 900. So, kind of jump forward here. I'm going to try to put it in order, all in one step while multiplying. You okay with that? Okay, so 4x cubed, okay, minus 120x squared, plus 900x, minus 1,000. Now what we have is a polynomial set equal to 0, okay? So we have to find an x value that's going to make this 0, and then we synthetic factor to factor this all out to find out the possibilities for x. Okay, so let's. A lot of factors of 1,000. Let's see if we can find one very quickly. So first thing we should have looked for, just to make everything a little simpler, is the greatest common factor. And it turns out 4 is the greatest common factor of all of these. Okay, which means we now are left with 0 is equal to 4x cubed minus 30x plus, I think it's 225x minus 250. Okay, Now we can work on factoring that polynomial there. Might be a little simpler to look through. Still a big number at the end though. Okay, so going back up here, we discovered that 10 is one of the factors, so we're going to use synthetic division for that. So because positive 10 worked, we have 10. So we write down our coefficients 4, negative 120, positive 900, and negative 1000. We have 4, which is 40, negative 80, negative 800, 100, positive 1000, 0. So our new coefficients are x is equal to x minus 10 times 4x squared minus 80x plus 100. All right. Again, you can take that greatest common factor out here. So we take 4 out of all of these terms. So we get 0 equals 4x minus 10, x squared minus 20x plus 25. And in order to factor this part, quadratic equation. So x is equal to negative 20, because that's our b. Do you remember the quadratic formula? Yeah. Square root b squared. So negative 20 squared is 400. I'm just going to try to go into this. 4 times a is 1, c is 25. And it's all going to be divided by 2 times a, which is just 2. So we are going to get positive 20 plus or minus 4 times 25 is 100. So we're looking for the square root of 300 divided by 2. Is that okay so far? 20 plus or minus square root of 300. 17.32. 2. Split it. Our x values are 20 plus 17.32 divided by 2. X equals 20 minus 17.32 divided by 2. I'll do the second one. 17. This gives me 1.34. Did you do the other one?
Yeah, it's 18.6.
6?
Yeah.
So there you go. Okay. So we could leave it in a fraction form, technically, but we already are working with decimals. So our options are,
How would you know which one is it?
so we can plug them in. We have 3 values, right? Our x values now, that we solved them all, are x is equal to 10, because we knew that was a factor. X is equal to 18.66, and x is equal to 1.34. Okay. Now we go back to our very original stuff. We'll go to the next page here for this. So to check this, we go right back to our original formula, which is volume is equal to length times width times height. We knew the length was 30 minus 2x, right? So right off the bat, that would give us width is 30 minus 2x, and your height was x. Okay. So in this case, say it was 10, that'd be 30 minus 10, 20, which gives us 10. So we have a length of 10 for our first option, width of 10, and a height of 10, which would give us 1,000. So factor by grouping, we put this together in a group. We factor out 2x squared from each of these. What can I technically factor out of here for a greatest common factor?
1.
Yeah. So, squared, 2x squared. 2x squared goes to the outside. My 1 is technically outside. Obviously, it doesn't change anything. And now what I'm doing is I'm doing the exact same thing, but I'm taking out a common factor. The common factor here is x plus 1. So I take out my common factor, x plus 1, and I'm left with 2x plus 1.
Okay.
Okay.
I'll just do 1.
here. Another way to look at this, let's say I said let x plus 1 equal y. So let's say I replace both those brackets with y. What we'd have in is 2x squared times y plus 1y, right? And then we can factor y out of both of these. Okay? So then what we have is y times 2x squared plus 1. But our actual value of y is this. So I replace it with x plus 1 times 2x squared plus 1. Does that idea make sense? It's just that normally we're used to seeing it as just one variable, but these brackets still mean one number. We just don't know what it is, so we're factoring the brackets out as a t. I should have wrote these in a different order. Think of them as like a common factor, and we've taken it to the front.